Hello viewers, welcome to UN College Digital Class. Today I am going to discuss about the operators. Already in the previous classes we have discussed about lots of operators. Operators are some special symbols which specify or which represent what type of operation will be performed on the operands. Today I am going to discuss about a special type of operators which is very interesting one. Let us start. Today we will discuss about one interesting type of operator, that is bitwise operator. Actually when you are writing a program, you interact with byte. Okay, byte consists of number of 8 bits, but if you will interact each bit individually, then C++ provide lots of operator and those are called as bitwise operator. In the bitwise operator are used to perform bit level programming. What is the meaning of bit level programming? Suppose you are entering two values, let int a and b, and you are performing number of arithmetic operation or logical operation, etc. Then in that case you are using a and b as individual unit. It means that whole a, it means that 16 bits are used as one unit and 16 bits of b are used as one unit. But if you want to handle each bit of a, integer a, individually, then in that type of programming, that is called as bit level programming. And to perform bit level programming, bitwise operators are used. And the bitwise operator are used for performing testing operation. It is used to set number of different type of status, shifting the actual bits, etc. As a definition, you may say that bitwise operators are used to change the individual bits in an operand. Actually when you are performing arithmetic addition operation, at that time you are using the 16 bits as one unit, but bitwise operators are used to change individual bit. Now we will discuss the application of bitwise operator. Actually it is one of the very interesting question, because number of operators are used in C++ and those operators perform very effectively on the different type of data types. Then one interesting question may be arise that then what is the necessity of using bitwise operator? Actually bitwise operators are used for performing encryption, data compression, networking, interfacing hardware. Encryption. Encryption, you know that it is used in computer security to secure data. During transmission we need to encrypt our data, and in encryption you need to handle each bit individually, and to handle each bit individually we use bitwise operator. Then data compression. Suppose you want to store data in a compressed format, and during transmission suppose you want to send data in a compressed format, at that time also bitwise operator is used. And in networking protocol also bitwise operator are used. And interfacing hardware, we know that there are so many different types of hardware devices, and each hardware device is detected by the operating system by using true or false, by using a flag, and for that we also need bitwise operator. Now there are these some operators are used as bitwise operator in C++. Those are bitwise complement, left shift, right shift, bitwise AND, bitwise XOR and bitwise OR. We will discuss about each operator individually so that you will be clear on this concept. Now first of all we will discuss about bitwise AND. Bitwise AND operator is a single ampersand, that is single ampersand one, but in case of AND operator, logical AND operator, we use double ampersand. When we are using logical AND, it means that we are combining two different conditions, two different operand, two different return type, whatever. But when we are using bitwise AND, we used single ampersand, and it is used, it is represented in the truth table. Let we have used here two values a and b. All the bitwise operator perform on bit. So here either the bit is 00 or 01 in this way. So suppose we will represent the one truth table here by using the ampersand or AND operator, so that it will be clear for you. Suppose the two value of bit are 0, then by using AND operator the output will be 0. Suppose the one value is 0, another one is 1, then the output will be 0. The same thing will be here, and if the value is 1 1, then the output will be 1. It means that the bitwise AND operator represents, or the output of the bitwise AND operator is 1 if the two operands are 1. Otherwise, in all the cases the output is 0. If the two operands are 2 0, then the output will be 0, 0 1, then the output will be 0, 1 0, then the output will be 0, but only in one case the output is 1. Now, we will take one example of bitwise AND operator. Let we have used here two integers 12 and 25. Now, yes, actually whenever you are entering any value, that may be a character, that may be a float, that may be one integer, everything is converted into binary. Okay. Suppose we have entered here 12 and 25, then the 12 binary equivalent is 0 0 0 0 1 1 0 0, and 25 binary equivalent is 0 0 0 1 1 0 0 1. Okay, this is binary equivalent. In case of bitwise operator, what happens? Each bit is interacted, each bit is manipulated individually. How? Now, this is 0 0 0 0 1 1 0 0, it represents 12. This is 0 0 0 1 1 0 0 1, it represents 25. Okay. Now, we will calculate. Okay. 0 0 0 0 0 0, we know that by using the bitwise AND operator, the output will be 1 only when the two operands are 1. So, here 1 1, the output will be 1, otherwise in every cases the output will be 0. It means that the output will be 0 0 0 0 1 0 0 0, which is decimal equivalent is 8. Again, let me explain it again. 0 1 0 0 0 0 1 0 0 1 1 1 0 1 0 0 0 0 0 0 0 and the 0 0 0. In this way, we will get the output is, that is 8. Now, I am going to represent the bitwise AND operator by using a program. Has include IO stream using namespace std. You know what is the meaning of this. Then int main, yes, I may write this program by using class and object, but for simplification I have used only main method here. I have used int a equal to 12, b equal to 25. Just you may use this two statement or you may not use, that is not a issue. Here I have just displayed the value of a, then value of b, then cout a ampersand b. It means that here we are using the bitwise AND operator. Here we will get the output, that is 8. When you will execute this program, you will get this the output 8. Then the next operator, that is bitwise OR. The bitwise OR returns 1 if at least one of the operand is 1, otherwise it returns 0. Now, we will discuss this concept by using a truth table, so that it will be easy for understanding. Here I have used a and b, two values 0 and 0 and OR operator here. If the two values are 0, then the output will be 0. If the one value is 0 and one value is 1 here, then the output will be 1. In this case, here the value is 1 and here the value is 0, then the output will be 1, and here two values are 1, so the output will be 1. It means that it returns 1 if one operand is 1, and it will return 0 only when the two operands are 0. It is very simple to remember and easy to understand. Then here we will again discuss bitwise OR operator by using one example. I have used two integers here 12 and 25, and we know that we have to convert 12 and 25 in binary format before execution. The binary equivalent of 12 is 0 0 0 0 1 1 0 0, and the binary equivalent of 25 is 0 0 0 1 1 0 0 1. Then when we will perform bitwise OR operation on 12 and 25, then the output will be, we know that, we have to just remember the rule. The rule is that if one operand is 1, then the output will be 1. If the two operands are 0, only in that case the output will be 0. Okay. So, here the output, let us start calculating 0 1 1, 0 0 0, 1 0 1, 1 1 1, 0 1 1, then here the triple 0 are here triple 0 are here. So, the output will be 0 and the binary equivalent is 29. Now, we will discuss the program on binary OR operator. In the program of binary OR operator, we have started here has include IO stream, then int main. Instead of int main, you may write void main also here. If you will write void main here, then there will be no return 0. Then int a equal to 12, b equal to 25. And when we will perform the OR operator here, we will get the output 29. When you will execute this program, you will get the output 29. Now, we will discuss about bitwise XOR operator. XOR operator is totally different from AND and OR. It returns 1 if and only if one of the operand is 1, if both the operands are 0, or if both the operands are 1, then it returns result is 0. Now, we will explain this one by giving a truth table. Here the two operands are 0. So, the result is 0 here. Here one operand is 1 and the other one is 0. So, the result is 1 here, and here the one operand is 1 and another one is 0. So, the result is 1 here, and in this case the both operands are 1. So, the result is 0. It is also very simple one. Here you just remember two things, it will return 0 when two operands are 0 and it will return also 0 when the two operands are 1. Now, we will explain it by giving a simple example. Let I have used two variables here, one is 12 and another one is 25, and these are the binary equivalent. When you will perform XOR operation on 12 and 25, the decimal equivalent will be 21. How? 0 1 1, 0 0 0, 1 0 1, 1 1 0, 0 1 1. It means that here it will return 1 when one of the operand is 1 and the other one is 0, and it returns 0 when two operands are 1 or two operands are 0. Now, I will discuss it by giving a simple example. Has include IO stream, then int main. I have used int a equal to 12, b equal to 25 here, then cout a XOR operator b. When you will perform this operation, you will get the output 21. Now, we will discuss about bitwise complement operator here. The bitwise complement operator is an unary operator, works on only one operand, and it is denoted by tilde symbol, and it returns 0 to 1 and 1 to 0. This is the truth table. If the operand is 1, then the output will be 0, and in all other cases the output will be 1. It means that when you are taking 4 bits, okay, that is a nibble, then in that case if the value is 0, then that is 1, then 0, then that is 1. If it is 1, then that will be 0. If it will be 0, then that will be 1. It is very simple to understand. Now, we will take one example, that is 35. The binary equivalent is 001 00011. By using bitwise complement operator, we will just reverse the values. How? 1 to 0, 1 to 0, 0 to 1. In this way, we will get this one output. And the program will be int main, int num equal to 35. Here I have used also another variable, int num2 equal to minus 150. When we will perform complement operator on these values, then we will get totally different value. I hope you will execute this program so that you can understand it very clearly, but still if you have any doubt, then write to me in the comment box. Now, we will discuss about shift operator. There are two shift operators in C++, one is right shift operator and another one is left shift operator. Now we will discuss exactly what happens when we will use right shift operator, and then we will discuss about left shift operator. In case of right shift operator, what happens? All bits shift towards the right by a certain number of specified bit. We will take one example so that you will be clear on this concept. When we shift any number to the right, the least significant bits are discarded while the most significant bits are replaced by 0. How? Suppose you have used 0011 here and we have used here 4 digit number 0011. When we perform a 1 bit right shift, here we are just using right shift operator by 1 bit, then in this case each individual bit is shifted to the right by 1. As a result, the rightmost bit is discarded while the leftmost bit remains vacant. This vacancy is replaced by 0. Here the output will be 0001. The previous value, the operand is 0011, but when we will perform right shift operator, we will get output 0001. Then we will use left shift operator. The left shift operator is exactly reverse of the right shift operator. It shifts all the bits towards the left by a certain number of specified bits and it is denoted by this symbol. Now, we will give one example so that you will be clear. Suppose the 4 digit number 1010 and suppose we will perform 1 bit left shift operation. Then in this case, all bits are shifted towards left by 1 and the leftmost bit is discarded. So, here and the rightmost bit which is vacant one, the replacement bit will be placed with 0 value. Here the original value is 1010 and by using left shift by 1 bit we will get output 0100. This bit will be discarded. Now, I have used one example, I have used one program and I have performed left shift and right shift operation. I have used here int num 212, you may use any value here, then actually I want to show you that when you are shifting only 1 bit, then what happens, when you are shifting 2 bits, then what happens, and when you are shifting 3 bits, then what happens in this way. And I have used a loop here in which I have used from I equal to 0 to I less than 4. It means that it will continue 0, 1, 2, 3 and in each iteration you will get the output of right shift operator. How the right shift operator is working with 0 shift, with 1 shift, with 2 shift in this way. Similarly, in this loop I have used I equal to 0, I less than 4 and here also I have used left shift operator and you can see the output that how the left shift operator is working in case of 0 bit shifting, 1 bit shifting, 2 bit shifting, 3 bit shifting in this way. You have got some basic ideas on the bitwise operator and but still if you have any doubt then please write to me in the comment box. Thank you so much for watching.